Wonderful. Hello. You lot get like the special extra thank you prize of making it to a security talk at 3 p.m. on the last day of a 3-day conference when it's also a Friday. And I'm pretty much one of the few things holding you back from enjoying your weekend. So it says a lot about you. I'm proud of you. Now, it is a small group. Now, the beauty of a smaller audience for a talk is that if you have questions, if you have a scenario that you're thinking about when I'm speaking and you want to ask that, this is actually a really great opportunity to do that. So use this. There's no silly questions. There's, only questions that you don't ask for whatever reason. Okay, so let's get onwards. Let's check the clicker works. Right, so hello everyone. My name's Laura. I have been speaking at conferences for a wee while. Some of you may have encountered me before, but those who haven't, I've had the typical software engineer to security adventure, where it was completely unplanned, deeply erratic, and none of it would make sense if you spoke about it on your CV in a logical order. But I started out doing COBOL development on taxation systems when I was 17. And I've done everything from AI and robotics through to counterterrorism for the UK government, real-time radiation monitoring software at CERN. So I've been kind of all over the place. And I am deeply, deeply excited about software. Now, as a security person, that makes me relatively unusual because many security people are quite reserved when it comes to what we're building. They're like, kind of, slow down. Whew, why would you do that? Let's not do that. I'm more of a yeah, let's do that. What could possibly go wrong sort of person. Spoilers, lots of things, but that doesn't stop us from doing it. Nowadays, I run a company called SafeStack, and I specialize and have done for the last 15 years in helping very fast-paced dev teams of every shape and size put security through what they're doing. In this talk today, I'm going to share a lot of what I've learned on that journey. I wrote a couple of books. My mom is proud. That is about the only reason that I put them on there. Libraries have them. So look at that. Right, clicky thing. Right. Now, there's only a small group, so I get to see if you do this. So phones out, everyone. You heard me. Right, I'm here all day. I'm doing a survey, more specifically my company is. Now, this survey is asking all of about 7 questions. The data is completely anonymous, and I'm surveying as many organizations around the world as humanly possible to try and see what the real maturity of AppSec is. Because all of the data we see out in the world, all of the guidance is written by giant organizations with giant budgets. But the reality is there are 30 million software developers in the world right now, and they're building everything from scrappy things that they just threw up on Azure this afternoon through to giant complex banking systems and things that are going to go into space. So I want to understand where we're at maturity-wise. So you can help me out by doing that. All of the data will be open sourced at the end of the survey. So you'll be able to have a look at it and see what the trends are for yourself. And I'll also be sharing a report that shows the real state of maturity by organization size, people employed in the space, how much is going on. So thank you for those who contributed. Here is a story so far version. Now, what I found really, really interesting is we've talked to organizations ranging from 2 people to tens of thousands of people. And only 2% of them actually know what they're doing when it comes to AppSec. The average size globally of AppSec teams, does anyone want to guess how many people are on average inside an organization employed in application security? Less than 1. 0.5. That's amazing, isn't it? Oh, and it's not, it's terribly sad. But this is what we're dealing with. Now, the reason I show you this is not to say, hey, you should be like those 2%. It's to say, be where you are right now. If you're in that 2% and you happen to work for Microsoft, Sarah, yeah, then cool, good for you. Raise your hand if you're not in that 2%. If you work for an organization that is somewhere else. I definitely am. It's okay to start where you are. application security isn't about a magic tool that you put in the right place and ta-da, it's all fixed. It's not about having the perfect approach. It's about doing things a little bit different each day that add up over time. And it's doing it in an environment where the bad thing, the monster that's going to come and get you, changes all the time. So it's an unwinnable problem. You may as well just not stress it too much and just try and be better each day. Now, the reason I do this talk in particular is I get a little bit frustrated with the way we do security right now. In software security, we are very, very singular focused. Now, I like this diagram. This is from, the before times when we thought we were the center of the universe. And now our equivalent is that software coding is the center of the universe. That, all of the things you'll see out there about security talk about secure coding. Even the sector definitions, when they talk about the security industry for application security, entirely and only reference secure coding, which is awesome. How many of you are not a coder? You do something else in software? How many of you work with somebody on your team who isn't a coder, but if they went away, it would hurt? The rest of you don't. You might be lost. If not, you can have a wild ride. Right. So, for me, my strongly held belief is that software is a team sport and always has been. While we don't have software without code, we wouldn't write the right code at a high quality without all of the roles in our software team. And that includes our analysts, our architects, our developers, our testers, our UX people, our product people. All of these people contribute, and without them, things get a little bit hairy. We've all worked on a team that just sort of flies by the seat of their pants and just codes. Any of you still on that team? Yeah? You've seen your Jira backlog and it's 4 words on different cards. Login. Great, let's do it. Those still exist all over the place. But for many of us, we've moved past that. And we now have some form of design, some form of analysis, some form of thought goes into our software before we build it. And we have our entire software development lifecycle. And it happens, and sometimes it happens fast, and you're all DevSecOps and CI/CD and, a million times a day. Yay, good for you. Raise your hand if you are not really entirely DevSecOps yet. Any of you? Yeah. Spoilers, I work with a lot of companies, about 1,500 at this point, and I'd say about 20% of them are entirely CI/CD DevOps, and the rest of them are beautiful chaos. So if you're not there, that's cool. If your process still looks like a bit of a waterfall, it's cool, not going to judge. If your process is slow, doesn't matter. We can put security into every single one of them. It doesn't have to be DevSecOps. It doesn't have to be CI/CD. It doesn't have to be continuous. It just has to work for your environment, the one you're coding in and developing software in right now. So in this talk, what I'm going to do is I'm going to go through this entire life cycle because we've got a bit of a problem. All of our security guidance focuses here on the bit where we write code in our pipeline. In fact, all of the tools, even in the talks we've seen at this conference, have been primarily focused here. So people who use Sneak or Dependabot or any of the tooling for spotting vulnerabilities in your code, it's at the code stage. Any of you using SAST or DAST, great tools, wonderful, all at the code stage. So let's see what we can do that is broader than that. And let's see what we can do that brings in the entire team and not just people writing code. Now, there's 2 reasons for doing this. Firstly, yes, absolutely, we should be doing stuff in the coding stage, but you lot are already busy. So we can take some load and share it by bringing it earlier. Secondly, I believe that diverse perspectives breed better results, and your testers think differently to you. So do your UX people. So all of these brought together will make you more secure. Now, this is the annoying kind of talk where you're going to get homework. Sorry, not sorry. The last slide of this deck has a link to this slide deck. So you can actually take it away at the end, like a little workbook, and say, Laura gave me work to do, and off you go. I've never actually had someone report back and say they've done their homework, but if you want to be the first, then, go for it. I'll send you a sticker pack or something. So it's not just the SDLC that is causing this blind spot, though? It's in everything. It's in our marketing. It's in our language. So one of the things I would encourage you to do after this talk is stop talking about secure coding. Please start talking about secure development, because it's all about the entire process, not just the code. Right, okay, so we're going to start here with our current approach. Now, one of my favorite solutions to secure coding that I hear every single time I talk to an organization is, we don't need to do this because we only hire senior developers. And senior developers know how to do security. Raise your hand if you're either old enough or grey enough or wise enough to be counted as a senior developer now. Yeah, I'm definitely grey enough. How many of you do? You know all your securities and you're like, yeah, I totally got this. I don't. I've been doing this for 15 years and every single day I learn something new. Just because somebody has been doing software development a long time doesn't mean they know security. It means they know this weird experience pool from their adventure. So we can't keep pretending that when we hire seniors, this problem goes away. We also say, well, our teams write really good code. Cool, absolutely, wonderful, love your work. How many of you have ever had a linter show you a problem with your code? How many of you have ever written a test and then it failed spectacularly because you got the logic wrong? How many of you didn't find out until it got to production? Aha! We write bad code every day, not intentionally, and it doesn't matter if you're senior or junior. Mistakes happen. Security is just a category of mistakes at the end of the day. So, we are going to show you, I am going to show you in this talk, how you're going to involve all of these roles in security. And we're aiming not to disrupt your lives because you have too much work to do already. We're aiming for one little change. I'm going to ask you to try and dedicate just 60 minutes or 1 hour of security every sprint. So if you looked at what you do with your average week, that's really not much time. We call it the 1 hour appsec challenge. Now, I've been playing Pokemon Go as I travel, don't judge me. And I've wasted more time this week trying to capture little ducks than I have an hour. Definitely, I could have done a lot of security in the time that I have been chasing around imaginary creatures on my phone. So if you know you have an hour you can find over 14 days, imagine what we could all do if we did that. Imagine how powerful your team could be if in an 8-person team you had 8 hours of security every sprint, which is a whole day. That's a lot of work that we could get done and it wouldn't get in the way. So let me show you how you can do that work, because that's the important bit, right? Now, here's my absolute guarantee. Yes, I am the CEO of a security product company. Yes, we do great stuff. That's the only mention of that you're going to get from me today. If you haven't come and spoken to me, come talk to me. That's cool. But I'm going to give you a whole bunch of stuff you can do. There are no paid-for tools in this talk. There are no proprietary secrets you cannot find and find more information on the internet. That is my absolute hand-on-heart promise. So let's get going. Let's start with design. Raise your hand if you consider yourself an architect. Right, there's 2 types of architects I find in organizations. There's the architects who have done an architecture course, like TAFE or whatever, and they have a certificate on their wall, and great, wonderful. And then there's the architects who are the people who've been in the team for so long that they're the only one who knows how it works anymore. Now, I don't judge which category of architects you have in your team. But I want us to remember that actually architecture isn't a formalized practice for most organizations. And we can all, whatever our role, think a bit more like an architect. An architect is somebody who just designs things. Now, you may not do the perfect Visio diagram. You may not know, every design pattern that like they showed us for the well-architected talk just before mine. But I'm sure if I asked you to get a whiteboard and just sketch out roughly what a thing would do, you'd invent something. You're an architect. Now, our architectures are very complex now. The days of us having a nice polite box where everything fit on one sheet of A4 paper are long gone. Architecture is important to security because our systems are so distributed, because they are so broken down. Historically, our systems were quite homogenous when it came to technology. They were all the same kind of things. You would say, oh, we're a .NET shop and we use this database and this hosting. But now many organizations, probably most of you, are lots of technologies. You'll use the right technology at the right time for whichever component you're working on. And that's a really sensible way to do architecture. You don't want to try and get .NET to do everything if it needed a Lambda or some form of ephemeral computing. You don't want to get Node to do anything, really. But if you do want to use it, you're going to use it somewhere fast-paced and probably front-end. You're not going to sit it in a batch processing system and hope it takes care of payroll for a whole country. You're going to pick the right tools for the right job. Now, architecture isn't really about Visio diagrams. So I don't want all of you to go away and go, hey, team, I need to get better at diagrams. Architecture is about thinking through a system or a situation and then planning the controls and decisions you're going to make that reduce the risk. Now, let me show you a scenario. I want you to imagine for a second a bear has just walked through that door by our lovely volunteer in the blue t-shirt. Now, that bear, tell me about the bear. What do we know about bear that's just walked through a conference room door? That is a carnivore, yes, that didn't change. Does have claws. Feel the bear, be the bear. How is the bear feeling right now? Tired? Hungry? Probably very confused. It's just navigated 3 sets of moving stairs and downtown Sydney, and it's not native to Australia. Like, this is a very, very confused bear. Now, what does a bear eat? I put honey, but I don't think that's true. Why would it be interested in any of you? What did you bring with you today? You bought your bear snack box. That nice little set of internal organs in the middle with no bones protecting them. Fantastic. Right, so now in your head, some of you have already processed this scenario and you've made some decisions about security. Raise your hand if you are already looking for the exits and trying to figure out which door you were going to go through. Who's going with, I'm just going to build myself a chair barricade? Who looked at the person around them and went, I think I'm faster than them, I'm fine? Yep, cool. And who was the Instagram bunny who's going to die first because they wanted to take a selfie with the bear? Yeah, there we go, camera guy at the front. Always the camera guy. Well, we would only have to find out. Now, I'm not that level of experimental security person, but maybe next time. Now, if we were to try and then look at the architecture of this situation and what controls we can put in place to reduce that risk or the impact of it, we could put bear traps everywhere. Wonderful. We've stopped it. Never going to be able to get to us because there's going to be bear traps. Now, it's going to make getting out of the room quite challenging or moving around. So our system's availability is probably not good right now. But, you know, we reduce the risk. This is the equivalent of locking down your app so much that the usability sucks now. We could also go for a more detection route. So if our bear traps are preventing bad things from happening, our cameras would be detecting it. So this is how you use logging and monitoring in your systems. We're going to see the bear on the camera, and that way we can move in advance because we'll know where it's coming from so we can move around so it never comes near us. And that's a detective control. So architecture in security and in software is about picking the preventative controls and the detective controls you put at every component in your system. And it does look different depending on which component we're talking about. Now, this is a contrived example with a bear, which is highly unlikely, but at least it's a fun one to talk through. What we're really talking about here is this concept of a zero trust environment, an environment where we make no assumptions about the inherent ability of it to be safe, and we make architectural decisions to implement security controls that will prevent bad things from happening, detect them when they do, and respond appropriately if a bad thing slips through the net. Now, in apps, that looks like this kind of thing. I'm not going to go through all of these. Some of these words you will be familiar with, some of which you might have to go look up. But you would, if you looked at your whole system's architecture, probably be able to pick out a few of these that you already have. Our job as fledgling architects is to look at our systems and for each component, pick the controls we need to put in the right places. Now, raise your hand if you're fundamentally very lazy. I am. I think it's what makes us good engineers. We don't like solving boring problems manually time and time again. Now, this is a pre-made design pattern, a security architecture for a payment system. In fact, I'm about to show you on the next slide here, there's a whole bunch of pre-made architecture patterns that could guide you on this. So if you're just getting started with architecture and you want to think about things like threat assessment and threat modeling, so identifying whether a bear is going to come in and attack your system or what your equivalent of a bear would be, and then it gives you resources and tools to choose those controls, choose those improvements. So, as I said, you can get the slides at the end, but things like OWASP Threat Dragon, which is a tool where you can model your system and automatically generate an architectural review and what controls it might be missing. The Threat Modeling Cookbook, which is where that last diagram came from, it has a whole bunch of pre-made design patterns for security architectures, for common components. Great. Threat Modeling Manifesto, that's another set of resources. And the Awesome Threat Modeling is a GitHub repo, which I don't know the guy who looks after it, but he has dedication to the cause. There's about 200 different items on that list of resources you can bring to your team in the architecture phase. So please go check those out. Now, raise your hand if you'd only heard of OWASP for the OWASP Top 10 before, and you're like, what, there's other OWASP stuff? Yeah. Security is really bad at this. Go look at OWASP's website. It has the most phenomenal set of free books, cheat sheets, tooling that you've never heard about, but probably should be using. Right, so your action, I'm going to give you homework for the section. Draw your system design. Now, I don't care if it's scrappy. I don't care if it's on a whiteboard. I want you to draw it out, warts and all of the components. And don't do it on your own. Bring your team, because you might learn something. Then I want you to have a look at that and figure out the things that could go wrong. For those who've met me over the last couple of days and come and robbed a bank with me or hacked a doggy dating app, that's what we've been doing all week with you. So have a go at that for yourself. That's going to set you in real good stead for then making your design choices and good decisions at coding. So let's get into the coding stage. This diagram here, now this screen is very, very light, so I apologize, there's not much I can do. But this is from amvanker.org, and it is a visualization of nodes, the node ecosystem, NPM, and the interconnection between the packages. Now, we've been talking about this as a security problem for a number of years now. This is, you have inherited a third-party package and it's got a vulnerability type of issue. Now, raise your hand and be honest, if you had a slight bias when I said it was Node, your brain went, of course. And then, yeah, there we go. How many of you are .NET developers and were feeling slightly smug? I just want to show you why you're not to feel smug. Right. What we're talking about here is called transitive risk. All software is connected to each other. You do not write everything from scratch. You inherit components and you choose those components and bring them in. And in turn, they inherit components. And so if you were to map out the entire world of software, it would be like a beautiful constellation. Now, if you've done any reading about network effect or graphs, like nodes and edges graphs, then there are some really interesting concepts in that make it really vulnerable to be part of a big graph. Things like having a node in a graph that has the most power to disrupt the connection between all of the other entities. We call these items bridges. There's a really great free book from the University of Oxford, and I can get the link afterwards for anyone who wants it, that is all about network effect and impacting networks of people by disrupting or harming nodes in that network. And it makes you think about software very differently. So we have transitive risk. Now, you will write bad code. I'm not going to focus on that today, but I do want you to really think about the code you inherit. Now, while NPM and Node has a bad reputation, it largely comes from the fact that there are many, many more packages in NPM than there are in other ecosystems. But while you may be inheriting more packages, what do you think the average package length is in NPM in terms of lines of code? Yeah, it's tiny. It's like the perfect pull request size. You could read every line, it's glorious. Now, let's think about the .NET world. How big are your packages? Ginormous. You don't just go, I'm going to, do a like padding to the left thing and you pull in an entire framework, and it's literally millions of lines of code. Now, why am I mentioning this? Well, because one of the things we have to do as engineers at this coding stage is decide, is this safe to use? Now, we have a bias. I have a bias. You probably do too. When we look at items of code and decide to use them, that we may not be following a great process. We've actually gotten a few bad habits. I know I have. Raise your hand if when you're looking at a package, one of the things you look at is you just go, well, it's got that many numbers of stars and that looks great, so it must be popular. Yeah, stars are good, let's get that. Just a fun fact, completely unrelated. Do you know why I star things on GitHub? Because they make me laugh. That's my cue for funny thing. Stars are a really interesting metric. We think they mean different things to different people. How many of you have a process for when you're choosing a library where you actually follow that process and kind of think about things in a logical order? Oh, well done, you. Gold star, air high fives. If you don't, I'm going to give you one today. Here it is. I want you to make sure that everything you inherit, you have thought about just these things. So is it using a suitable license? Is it regularly released and governed by a well-sized community? Are there active and unresolved issues? Have you looked at the code? Now, I want to ask you a question. If you're looking at a peer's code, they sent you a pull request. How long do you spend reviewing that code? Raise your hand if you know full well if it's over 20 lines, you haven't got a hope of spotting the bugs in that. Now, this is where the NPM versus the Microsoft ecosystem thing comes in. That's the bit we never do. If you were to bring in code via a pull request, you would insist on doing a peer review of it before it came into your ecosystem. Yet, when we pull something off the internet, if it comes from something looking fairly reputable, we do nothing. We just go, oh, it must be fine. Get used to looking at the guts of the code you inherit. I'm not saying review of every line, but really do take responsibility for that. Now, .NET people, Java people, you're going to have a bit of a bad time. It might mean that you go join a community and go ask somebody who's done this before, what review process have they done? But still, it needs to be done. Does this package and version already have known security vulnerabilities? Now, things like Dependabot in GitHub can help you with this. That's wonderful. But please remember that just because it doesn't have known vulnerabilities, it doesn't mean it's secure. It just means that we don't know. Remember, our attackers are very efficiency-focused. If it's some obscure package that only 20,000 people use in the whole wide world, versus I'm going to spend my time on this thing that 20 million packages are relying on, which one are you going to do? An attacker is going to spend more time researching a more popular package and trying to exploit that than a smaller one. It doesn't mean that you're necessarily safe. So just be wary. It's a false sense of comfort when we rely on a clean bill of health. We just have to be vigilant. So what are your actions from this section? Right, I want you to take your new security review checklist. It's not hard. And the next thing you bring in, I want you to have a bit more of a structured review. I would love for you to turn on Dependabot or whatever you have in your ecosystem. Do not give a vendor a single dollar of your money for this. Not yet. If you're not doing it already, there are many free tools that will do this for you. And by the time you realize what you need it to do better, then you're ready to go and buy a vendor tool, not before. The final thing I want you to do is I want you to have an emergency plan. Now, the emergency plan is for when you find a vulnerability in a framework or a library that you cannot update. So how many of you have an old version of a library or framework that's in your stack for reasons? And that reason could be there is no new version. It could be that actually if you change this one library, everything is going to break and you can't go back and fix it. So have a plan for that situation. It's all very well that if vulnerabilities can be pull requested by Sneak and all of those nice tools, but if you can't do that automatic pull request thing, know what you will do instead. Okay, testing. Testing, 1, 2, 3. Testing is a superpower. Now, there is a bit of a misconception that folks will very often say, oh, well, you're a developer, so you're just, you're 5 steps away from being a penetration tester. You can be like an attacker. I'm going to challenge that. You suck. We suck as developers at looking for the bad things in a situation. We are wired to look at a problem and find a solution to solving the problem and getting it gone in the neatest possible way, the happy path. That is our way we are programmed. It makes us deeply unhappy to find the 27 ways something could be misused. I know this because when I ask you to rob banks down in the vendor hall, the number of people who come up to me and say, this is too hard, there's just too many ways to do this, it's every other person complains about that. Your testers, however, are agents of chaos. This is their happy place. So empower them. Make it okay for them to look at a system and go, cool, there's 3 buttons, I have 10 fingers, watch me go. And they're going to show you all the strange combinations that could happen. Let them be creative, give them space to do that. If your team isn't very good at this, find somebody who still embraces their inner child. That child who was like, right, cool, physics and the law are vaguely optional. What are we going to do next? Because that's what you need. You need somebody who can play. Test coverage is definitely not a leading indicator of quality. We know this. And now that Copilot can write our tests for us, then, easy, job done. Copilot isn't quite so good yet at writing security tests, but your team can be. Now, this is a cucumber-style test. So cucumber being the definition that most automation testers will be familiar with. Now, this scenario here is written in exactly the same way as you would expect, given, when, then. So given the user navigates to an authentication page, cool. When the user enters a username and a valid username, and the user enters a password but that's invalid, I want you to behave in this way. So this is testing that a password check works on an authentication page. You can write automation tests for almost all low-hanging fruit scenarios in security. There is no special tooling needed. And the beauty of this, if you take your 1 hour of appsec each sprint, for example, what if you just wrote one security test every sprint? And they can be quite generic. They can be reusable across multiple applications because they don't rely on the underlying technology all that much. That would be a very powerful thing for you to do in the testing stage that would be then reusable time and time and time again. You can link your threat model and your testing together. So if you're, robbing a bank, if your threat model says that my banking system is going to be attacked in this way by people stuffing credentials in, so using known passwords and trying to guess the passwords of an account, well, then you can look at that as your first test. So use those common scenarios you came up with in the architecture phase to then prioritize testing. Now, prioritize testing before implementing the solution. Why do we do that? The same way we always do testing before implementation, because then we know when we've done the job well. So a little bit of a housekeeping thing. Some of you may already use vulnerability scanners in your workflows. Now remember, if you were talking about human health, a vulnerability scanner is the equivalent of me coming and reading your temperature. It can be an indicator that you are sick if your temperature is really high, but it's not going to tell me how you're sick. It's not going to confirm you're sick. It's just going to tell me there is this bit of data and it says that your temperature is high. A vulnerability scanner looks for common patterns. It's essentially regex in a pretty box. And it says, hey, I can see this common pattern here, but you need to investigate further to figure out what this is. Automated testing goes further than this. This is the real value. So use your vulnerability scanning for your low-hanging fruit. Use your automated testing for confirming specific issues. That's the equivalent in medicine of doing a full diagnostic or doing a COVID test, to use the last few years as our example. We're not just saying you're sick, we're saying you're specifically sick and we have tested for this specific thing. So there we go. Don't rely on this one to do the depth of this one. It can't do it. It's not capable. Most security tools are productivity tools at their best. That's not a bad thing. They're there to do something that's very boring and takes a lot of time and do it for you. But remember that you're engineers. You literally build software for a living. So you have the ability to go above and beyond what that tool can do for your context. Now, a little bit of a note, you'll have a lot of people who say, well, you'll throw all of these things into your CI/CD pipeline and it's going to be great. and it's absolute rubbish. So a vulnerability scanner, for example, if it is configured in a default configuration or if it's looking for more than one category of bug, can take over an hour to run. Now, how many of you would be happy if your lovely built pipeline just exploded by an hour and every time you build, it's going to take that? It's ridiculous, right? You wouldn't want that. Everyone in your dev team is going to complain within the first 2 runs, or you'll get nothing done and everyone will be like, oh, I've got to build now and go and play games or whatever. What you want to be doing is looking at every intervention you put into your pipeline. You need to look at the respect of it. How long does it take to run? How much impact does it have on the team? And most importantly, do you have any time to do something about the results it gives you? If it's going to take too long, or you don't have time to address the results, you would be better moving it back to either a manual process or a parallel CI/CD pipeline that you can run on a different frequency. So, for example, you run it once a sprint. If it takes an hour, that could be your hour of appsec. And then you could use your hour the next sprint to review the findings. Now, is this ideal? No, we've taken time to get across it, but it's better than not doing it at all. So we're finding that balance between the practicality of it and the impact it has on our day-to-day, because we don't want to break what we do for a living. We have to find that. So I want you to stop talking about test coverage entirely, which most people have, thankfully. I want you to play. I want you to embrace your testing team, not physically, that's rude, but bring them in, buy them cake, and give them some space to explore, to go hack their own thing. Do it as a paper-based exercise if you need to. If you work for a health provider or a bank or an airline, sit in a room, make it safe, and ask them, cool, what's the worst you could do? If you went evil today, what's the worst thing you could do with the data you could access there? And for 5 minutes, they're going to be deeply awkward about the entire thing and think you're joking and you're trying to trick them and they're going to get fired. And then if you lead by example and you play along too, they're going to feel safer. And you'll find in a few sessions' time or a few weeks' time, they're going to come to you and they're going to go, hey, I've been having to think about this system and I think this could go wrong and I think we need to talk about it. And that is a truly powerful moment in the security of your software. Right, deployment. I love robots. Robots are amazing. For anyone who saw me last year and I did a keynote and had robots, I genuinely, like, when I have to get a real world grown-up job one day, I hope it gets to be with robots. That would be really cool. But in the interim, I have to do with a lot of automation. My mentors over the years have been fantastic, but they have been very military type men and they have been very focused on get rid of boring jobs. And they promised me and held me to the promise that if I didn't automate myself out of boring, repetitive jobs, I would do them forever. And so that's how I embraced robots. Now, security sucks. I do it for a living, but it can be really boring and really time-consuming, and it's full of checking really specific details in very specific scenarios. How many of you are naturally good at doing that and doing it consistently over time, every single time you do a pull request or every single day? None of us are. It's a horrible set of things. It's not a human behavior at all. But you're engineers. Your mind works differently. Your mind literally thinks of ways to automate things. So script yourself out of it. There are some wonderful ways you can do this. Just using GitHub as an example, but equivalents work in GitLab or in Azure DevOps. All of these actions here can be done for free, can be automated into your pipeline, or to just do it when you're locally on build, whichever you prefer. So SendGrep can run as a free SaaS tool, so a security analysis and software testing tool. TruffleHog, which is a cute name, can look for secrets and passwords in your code before you commit them. I won't tell anyone, but raise your hand if you know you've got passwords and secrets still committed in your, yeah. Okay, cool, extra homework. Run something like TruffleHog, get rid of them, and then roll those passwords, please. Just for the good of mankind and all that. Sorry? Working on it. I'm proud of you. Right. We can check for outdated packages using Dependabot. We can use linters. Linters are a security tool, even if they don't feel like it. So there's no excuse here. I want you to take one thing in security each sprint. If you're going to take your hour, go pick one boring security task you know you're supposed to do. Start with perhaps secret scanning. and write the little script or the little action that's going to do that, and make sure that from now on, no new passwords make it to your GitHub repo. That's a pretty cool goal, right? I feel as an engineer, I could achieve that in an hour. Great. So support. Don't worry, we're getting to the end. We're almost done. Right, this, my friends, is an incident response plan. Doesn't feel like it. It's the incident response plan you've seen most in your life. It is what do you do when something goes wrong on an airplane. Now, the reason they do these is because preparing for an emergency means that at the time of it happening, behaviors are more streamlined, the chance of recovery is higher, the speed of response is higher. Now, in incident response and security, it tends to be owned by, the serious business security department somewhere over there, the risk and compliance people. But I want you to embrace incident response at a software level. Now, by that, I mean you already handle incidents. An incident is, you had an outage, or a bug made it to production, or your queries are going slow today and you had to go and investigate. They're all incidents. Security incidents are just a subcategory of what you're already doing. And I want you to have a plan. Now, I'm a minimum viable documentation type of girl. So I don't mean a giant PDF, don't waste your time, but think about your airline card. Think about what's the quickest set of bullet points I could write that would tell us what to do repeatedly in this scenario. Now, I don't want you to just write them down. I want us to do a bit more than that. So incident response in security is a 4-stage thing. Identify a bad thing has happened. Now, in software, there's a few common pipelines for this, right? We spotted it in our logs. That could be it. We had an alert. It could be customer support have gone, hey, we've got like 50 different customers complaining they can't do a thing. Could you fix it or something? It could turn up on the news. That's a pretty horrible way to find out about an incident, if I'm completely honest. Let's not aim for that one. So we've got identification, and it'll be different for each of you of how you would find out it has happened. Next, verification. Now, I want you to imagine a scenario. Imagine you've had this customer support request. Oh, we've had an account that's been compromised. There are suspicious transactions on it. Great, cool. Well, the first thing you're going to do is look at that account, right? And go, well, what's happened? Whose account is this? Maybe it turns out that that account belongs to Taylor Swift. And if it belongs to Taylor Swift, then perhaps you've got to respond to that in a different way than if it was any of us, because we're just mortals. So we have to verify, and that gives us the priority, the impact, the severity, how likely it is we're going to end up on the news. Then we contain, so how do we stop it from spreading? And that could be turn it off, that's like the ripcord solution. Or it could just be, I'm just going to reset your password. Let's just kick all the sessions out of that account right now. Let's just see how we go. And you're going to have different things available to you. If you're in an authentication-based system, if you're in session-based systems, if you're in some mobile app distributed architecture, all of these have different scenarios you can play out. And then we have remediation. And this little bit here then loops and loops and loops until you're all fixed, right? You know this because you already instinctively do it when handling functional incidents. If it doesn't work, you already do this. So all I'm getting you to do is to build some playbooks for software security incidents. I've even given you some suggestions to get you started. So account compromise, password breach, unauthorized query or data export, data exposure, I can see other people's stuff, permissions escalation, unauthorized data access and view, suspicious changes to deploys or builds, out of hours changes to deploys and builds actually should trigger your incident response plan. So if you're the dev that's secretly deploying at 2 a.m., don't be that person, because I want you lot to trigger an incident response plan. So what on earth is going on there? Right, suspicious activity reported on a customer account. All of these are very generic. You'll be able to add some of your own for your scenario, but just start there. Get your bulleted list, your little card to grab in case of an emergency, and don't just get it. I want you to list these kind of things. So how do you verify? How do you contain it? What logs do you have and where do you find them? Who do you need to contact? What do you need to tell them? The sensitivity of the data that is involved in it. Where are the backups? When was the last time you tested them? Where do you keep a record of the incident? Do you have to write it down somewhere? Now, this doesn't need to be very detailed. Like I said, could just be a bulleted list. But just having it means that in the event of a crisis, when something bad happens, you're prepped and ready to go. Once you've got your playbook, your little checklist, I want you to then get the team together and practice it. So bring in developers, testers, bring some marketing folk in, bring in customer success people. And you want to role play it. Now, don't just read it and go, yeah, it looks fine. I want you to go find the logs you would have to go find. You might find that there are gaps in what you have available to you. That's a great way for you then refine it, check it's going to work outside of an actual crisis. So that's your last bit of homework. Create an application security incident response plan and some playbooks and test them. And if any of you were D&D geeks when you were younger, you're going to love that stage because it's essentially just role-playing. So where are we at? We've gone from the idea that security is a coding problem to little tiny steps we can take all the way through the software development lifecycle that we can split through every member of our team, and we can do it consistently over time. So we don't need to do a big burnout sprint. We can just do bit after bit after bit. And each time we will get stronger and more resilient. So what have I got for you? Well, I have the slides. You can go and get those at any point. I think we're good on time, but you can contact me here on the social medias. I'm Lady Nerd at various ones. I've given up on tracking which ones are alive at this point. You can find me at laura@safestack.io. Please connect with me on LinkedIn if that's your jam. And have a go. The most important thing you can do is try and share what you're doing with other people. The future of secure development does not belong to the security community. It belongs to the development community. All we need to do is give you the directions, point you in the right way, and then your engineering skill set is going to do the rest. So thank you so much for your time. If there's any questions, you are more than welcome. And please do remember to vote green at the end, because I know where you'll be the rest of the afternoon. Any questions? So the funny thing about Security Talk is nobody wants to ask a question because it's actually makes you feel very vulnerable to go, yeah, I work for this giant company and we're doing this wrong and help me. So if you're in that scenario and you know there's something specific to your context you want to talk about, just grab me in the next couple of hours and we'll just have a quiet chat. That's perfectly okay. The other thing you can check out, if you go to www.onehourappsec.com, that is a free AppSec program that gives you suggestions of what to do with your hour for the first 8 sprints. So that could be a nice way to get started. Right, you've been lovely. I was here. Oh, did you have a question?
Yeah, so OKR for this quarter, 45,000 new users.
Wow.
Ambitious, but there's nothing in there about security. So it's kind of hard to argue. It's a bad idea.
Yeah.
And
no, it's all right. I'm not judging. I'm not judging.
You have some tips for sharing the burden of having a system that is maybe less secure than it should be with the product?
Right, okay. So I'm going to repeat the question, not just for you in the room, but because there's people who are watching on the video at home. So there is a theoretical organization in the world that is going to try and onboard 45,000 new users as their OKR. That's pretty amazing. Like, oh yeah, kudos. I wish you this growth. But there's no security. And they want to know how can they communicate to the product space that security needs to be involved a little bit more, that this is important. So the first thing we need to do is security fails horribly when we come and say, your baby's ugly, you should feel bad, slow down. It just doesn't work. Now, I have a bias here. If you go to our website, there's a really great blog post, and I'll send you the link afterwards if you give me some contact details, of how security can work for product people. But the way I like to think of it is if you think about when you're scaling anything rapidly, there's going to be pain. And security can be a massive amount of pain. So they estimate at the moment that dealing with a security incident can distract a development team for 40 hours, just doing the initial triage and figuring it out. So that's 1 week of distraction away from your goal of getting these people on. And your product people aren't going to want that because they're going to have this list of things that these people are desperate for that they're keen to get out the door. If we do find something in our 40 hours, the average resolution time of a security issue can be as long as 3 weeks. Now, That's 2 sprints of total effort when something goes wrong. So you need to be able to have a prioritization mechanism that has some value to security. And for me, that value comes from my system is more reliable. It's going to be there and it's going to be usable and it's going to be fast and performant when my people come. The other side is, from an expansion point of view, many organizations, when they're selling to other organizations, will have to go through some form of procurement and due diligence. And almost every time, they're going to ask you a whole bunch of questions about how you look after their data and your practices around security. So getting even just a little bit of progress on your security can speed up sales. It could actually help get to the 45,000 quicker, but you need to frame it in the right way. Now, for many organizations in this particular market, capital, cash flow, is going to kill you quicker than security. And there's no point in me pretending otherwise. In a rough market where there's a lot of pressures and challenges, we have to be realistic. And so it makes it more important than ever that security is viewed and is in part of the growth mechanism and how we look more mature, how we operate more resiliently, and how we're ready to meet the needs of larger, more complex customers. If you want to go deeper, though, do reach me afterwards. Hello. If you don't do it, well, our CFO or CEO get locked up in prison. Yeah. Well, not me personally, but I probably forgot in the process. Yeah, absolutely. And I think I don't like to lead with the stick. I'm more of a carrot kind of person. But in Australia in particular, you do have a legal climate that is now preparing to have real consequences for this. So please do, bear that in mind. It is something to consider and think about. And the other side is, if you work for a smaller organization, if you work for a giant organization, there's reasons you're going to get attacked. You'll probably have a security team. They'll be very well aware of where the threats are coming from, what they look like. If you work for somewhere smaller, you may not have a lot of visibility of what threat really looks like to your company. So it could be that your product team or your wider organization don't know quite yet how it could go wrong. So perhaps doing an exercise like that threat model, just on a whiteboard, we're not there to point out all the horrible things in the world, but just to be prepared and understand why this might go wrong could be powerful. It could create shared language. Gentleman at the back.
So how do you see things like those in 2001 as a risk management of space across the organization? Positive or negative?
Wow. Okay, I'm going to repeat the question for the video users at home. So the question was, where does ISO 27001 and the various regulatory and compliance frameworks fit into security and risk management? And is it a good thing or a bad thing? And I feel like he's just asked me a really loaded question, but it's okay, I'm going to answer it anyway. So full disclosure, I'm a reformed auditor. So I have lived in that world. I no longer do that. It's been a long time. But there is a value to it. There's a value when you're selling, because it can go a lot easier when you say, hey, yeah, we've done the certificate. Ask us if you've got anything more specific on top of that. It can cut out a lot of drama and doubt. And the barrier to getting trusted by a new customer or existing customers can be easier. But it is just a framework. It's a security management framework. So it says, hey, we've thought about a process and we're doing this in a consistent way. But it's not really looking at the detail of whether that's working. And the metrics it cares about are not the ones that actually measure the security of your system. So use it as a tool, especially one that if you are looking for a framework to follow, finding a framework, whether it's a paid for one like ISO or a free one like OWASP SAM, the Software Assurance Maturity Model. You can follow those, roll out those programs, and it'll give you a structure to play against, which is great. But then I want you to consider what metrics you're using to judge what activities you're doing and whether they're successful for you. And you're going to be looking for not number of vulnerabilities you found. That's not a good indicator of security. But how consistently are these processes applied? Are they done by all teams? Are they done automatically? And we're measuring these leading indicators, the forward-looking measures of, does this control I have in place because of framework actually do the job? Your questions have been amazing. You've been amazing. It is almost 4 p.m. on a Friday. You are free to go. Enjoy your last talk of the day, and please come and find me. I'll be down at the SafeStack booth if you do want to have a chat about anything at all. And thank you so much for coming along.